Hello everyone. On this good day, we are going to discuss worksheet questions based on semiconductor devices. Identify the logic gate from the following with the same truth table characteristics of the logic circuit below. Okay. See the picture, whatever the circuit diagram is indicating. First one is A bar, below that is B bar, and both are NAND gate. NAND gate means A bar dot B bar, NAND means this one. That means this can be split into. So A bar bar plus B bar bar. Whenever bar splits, operator change. So this is A plus B. A plus B means OR. Yo. Yes. Next. Identify the logic operation. This is A bar, because whenever two inputs are joined and given, that will be A bar and B bar. Now these two are NOR operation. That is NOR implies A bar plus B bar whole bar. This is NOR. This plus this whole bar is NOR. That means A bar bar, B bar bar operation change. Operator should be changed. So A dot B. A dot B is nothing but end operation. So this is B. Next. Output of the following circuit is equivalent to dash gate. Again, this is A. Hey. Two inputs are given, but it is not a NAND gate. It is not a NAND gate. It is AND gate. So this is A only. Okay, if both zeros, both are 0, 0 only will come, both are 1, 1 only will come. So there is no other possibility, right? So A and this is B, both are connected to NAND, N-A-N-D, NAND implies A dot B whole bar. NAND only the answer, nothing to simplify it further. Next. In a NPN transistor structure, which of the following statement is not true? NAT. Emitter is heavily doped and moderate in size. Emitter is heavily doped and moderate in size. Correct or no? Base is lightly doped and thin size. Yes. Collector is lightly doped and large in size. Lightly doped. No, moderately doped. And collector moderately doped and large in size. Yes. So option C. The behavior of the circuit is like this is A and the other one is B. These two together is coming as A dot B. Next again A is taken, B is taken, and these two are together is A plus B. And these two are given as plus. That means A dot B plus A plus B. So which will come with this? A dot B plus A plus B. So how will you do? A dot B plus A plus B. This can be simplified. So I have a technique for it. A plus A dot B plus B. Just I wrote this A aside. A of 1 plus B plus B. If 1 is added to any input, the 1 only will come. Plus B. So it will become A plus B. A plus B is nothing but OR gate, right? A plus B is nothing but OR gate. Yes. And then NAND gate, A and B inputs and Y is the output. A and B are inputs and Y is the output. Okay, NAND. Then the correct option is A, B, Y. Y is equal to NAND A dot B bar. A dot B bar. 0, 0. Then AND will be 0 and output should be 1. So it's wrong. Or otherwise table I will put 0, 0, 1, 1, 0, 1, 0, 1. If A dot B is there, then 0, 0, 0, 1 and bar will be 1, 1, 1, 0. So 0, 1, 0, 1 should 1. So wrong. This is 1, 0 wrong. This is 1, 1, 0. This is correct. Yes. Next. What is output of the logic circuit shown below? Wow. That is 1 and x. Okay. 1 plus x. This output plus x. This output plus x. How many pluses? 1, 2, 3 plus x is equal to y. How many times you add x with x? X only will come, right? So it will be 1 plus x into y. Whatever. So 1 whenever added to something, then 1 only will come. So y is equal to 1 always. Y is equal to 1 always. Nice bit it is. In a PN junction diode, square input signal is 10 volt is applied. The output signal across RL will be output signal across 10 volts is applied. Okay. This is square. So negative 1 is dropped, only positive 1 will come. So yeah, because this is a rectifier, half wave rectifier. So only positive half cycle will come. Next, two ammeters A1, A2, okay, are connected as shown in the figure. By neglecting the internal resistance of the ammeter, the reading of ammeter A1 is, okay, A1. Whether the diode is conducting or not, diode is non-conducting because diode is in RB. Diode in reverse bias. As diode is in reverse biased, so A1 is equal to 0. Ammeter reads 0. No current flows in the circuit. Ding ding. In Zener diode, only P region is heavily doped, N region heavily doped. Both are heavily doped. Yes. PN junction regions are heavily doped. Next. Boolean expression of the circuit given below. Boolean expression. First we'll write this is A bar, B. Both are added. So OR gate. That means A bar plus B. So A bar plus B. Option C. A piece of copper, another germanium are cooled from room temperature to 77. The resistance of germanium increases, copper decreases. Copper decreases, germanium increases because semiconductors are absolute resistances at 0 Kelvin. So as you decrease the temperature, the resistivity increases. The truth table of logic gate is given below. Logic gate is given below. Then identify the gate. This is 0, 0 is 1, 1, 1, 1, 0. This is nothing but NAND gate. You need to know the tables. The circuit is given as A bar, B bar. This is NOR, followed by NOT. NOR followed by NOT is nothing but R only. Implies we are going to have A bar plus B bar. R means that only, right? So it can be A dot B whole bar. Yes. So this is nothing but NAND. Yeah. This is somewhat, it should be like this. Otherwise, I first thought that it is what you call NAND gate, but it is NOR gate actually. NOR. So anyway, in examination it will be clear on. Next. Which of the following statement is true? Is true. Okay. Which of the following statement is true? A solid is necessarily an insulator if its conduction band is empty. Okay. Next. The change in current through a junction diode is 1.2 milliampere. Change in current delta I is equal to 1.2 milliamps. When forward bias voltage is changed by delta V is changed by 0.6. The dynamic resistance R is equal to V by I. V by I. That means delta V by delta I. 0.6 by 1.2 milliamps. So it will become kilo ohm. 1 by 2 kilo ohm. 1 by 2 kilo ohm means 0.5 kilo ohm means 500 ohms. Option A. The value of Y and Z in the given logic circuit is. The value of Y and Z in the given logic circuit is. Y and Z. Okay. This is 1, 0 is given. Let me take up. I would like to do like this. 1, 0 will give you 0, and 0 1 will give you 1. If it is 1 and 0, this will be 1 only, and this is 0 only. So this is an and after that not. So and first will give you 0, not will give you 1. So y value is 1 first. Y value 1, two options are there naturally. Okay, this is 1 after just a diode, so 1 will come 1, and this is also 1 will give you 1 only. So both are 1. So option A. Next, out of the following logic circuits, okay, ding ding ding, goodness. First one is A plus B. Next one is A plus B. Next one is A plus B. What is this? A plus B, A plus B, A plus B. All are A plus B, A plus B, A plus B only. Maybe they are bubbles. If they are having bubbles, then story is different. If it is having a bubble here, bubble here, bubble here, bubble here, then I can think it as A bar plus B. And the next one is A bar, B bar. Next one is A, B bar. Yes, maybe they are bubbles. Bubbles are missing. A Zener diode is made up of heavily doping both p-n sides of p-n junction diode. Heavily doped both p-n junction sides of p-n junction diode. Heavily doping the p side and lightly doping the n side of a p-n junction diode. Zener diode is made by both the junctions must be heavily doped. Lightly doping, heavily doping p side, lightly doping, no lightly doping, heavily doping p side, n side of a junction diode. So option A, that's it. Next, if the bodies are ideal, diodes are ideal, the circuit current through the cell is how much current is delivered by it? D1 non-conducting, D2 is conducting. Why? Because D1 is reverse bias, D2 is forward bias. So circuit will take this place, ding, this, and here is D1 and ding, ding, ding. Yeah, this is 2 ohm resistor, this is 3 ohm resistor, this is 3 ohm resistor, this is 2 ohm resistor, this is 2 ohm D, this is D2. So 2 plus 3 plus 3 plus 2, 6 plus 4, 10. 10 ohms is the total resistance R. Then V equal to 20 volts. Then I is equal to V by R, which is equal to V by R 20 by 10. That is equal to 2 amps. Yo. Next, the truth table for the given below circuit. Truth table for the given below circuit. Okay. A plus B bar, A dot B, these two are NANDed. Yes, yeah. So this is A bar dot B bar dot A dot B whole bar. Yeah. A bar dot A will give you always 0. B bar dot B will give you 0. 0 dot 0 is 0. 0 bar is 1. All are ones. Option C. I'll tell you, A bar dot A is always 0. Okay. And A bar plus A is always 1. These two should be kept in mind. Next. When PN junction diode is in forward bias, which type of charge carriers flows in the connecting wire? Connecting wire always electrons only will flow. Only semiconductors only contains holes and electrons for our convenience. But current is carried by free electrons only in conductor. The resistivity of a semiconductor at room temperature is resistivity, memorizable thing. Resistivity at room temperature, 10 power minus 3 to 10 power 8. And 3 diodes, D1, D2, D3 made up of semiconductors having band gaps 2.5, 2, 3 respectively. Which one will be able to detect light of wavelength 600 nanometers? 600 nanometers means how much band energy, band gap? Nanometers, lambda. So Hc by lambda is equal to 12,400 by 6,000 because it should be in angstroms. So that energy will come in electron volts. So energy is equal to 2 zeros to zeros will go 124 by 660. Then 6 table will go 2 times 0.12 हो गया 4 came, nothing will happen. So 0 40. 9 roughly 8 no 7. Okay, 7 we can take. 2.7 okay, 2.7 electron volt. If it is 2.7 electron volt, 2.7 electron volt, first one will give, second one will give. So both D1 and D2. D3 can't give, right? D1 can give 2.5. If my calculation is correct, that is D1, D2. But there is no like that, only D2. What is that? Exact value? No, not exact value. If 600 nanometers light falls on 2.5, okay, it is 2 only. Okay, yes, correct. I am in domain of 2.7. It's 2 only, right? It's 2 only, 2 electron volt only. So only 2 will respond, or lesser ones will respond. 2.5, why and how it will respond? Correct one. Yes. Next, the circuit given represents which of the logic operation? A dot B bar, and this is a NOT gate, so it will be A dot B. A dot B means end. 220 volt supply is connected to A and B. What will be the potential difference across the capacitor? That is a half wave rectifier. So positive half cycle will come. Positive half cycle. So if I am expecting positive half cycle output, then actually even though it's a half wave rectifier, average EMF value only will be transmitted, but half of the power is transmitted. Voltage will be that only. So Vrms is equal to 220 only. But he is asking maximum. Yeah, the potential difference across V is, so V max is equal to peak value is equal to 220 root 2. So B option should come. In the following circuit, what are P and Q? Let me take. It's a nice one. It is. This is 1. Okay, and this output should be given to it as input, and this output should be given to as input. So we have to think, suppose the first option 0 I'll put here. First option 0 I'll put. Then this will be 0. Okay, then 0 0 will be 0 here, and it will be 1 here. So it will come as 1. 1 and 1. 1 and 1 is 1. 1 will become 0. So it is accepted. The first option is accepted, and I'm not checking the other two. You check like this. First select one P. Select one option P right there and check by doing a back calculation. Tricky question. Good one it is. The conductivity of semiconductor increases with increase of temperature because both number of density of charge carriers and relaxation time increases. Number of density of charge carriers increases. Number of density current carriers increases. Relaxation time decreases, but effect of decrease in relaxation time such that the relaxation time increases. Number of charge carriers increases is the correct one. Obviously relaxation time will decrease. The density of an electron hole pair in the pure germanium is 3 into 10 power 16. Electron hole pair density is, that is Ni is equal to 3 into 10 to the power of 16 meter cube. At room temperature, on doping with aluminum, the hole density increases to, that means NH 4.5 into 10 to the power of 22 Now the electron density in doped germanium is electron density equal to how much? You know, Ne into Nh is equal to Ni square. So Ne is equal to Ni square by Nh. You need to patiently do 3 into 10 to the power of 16 into 3 into 10 to the power of 16 by Nh 4.5 into 10 to the power of 22. In common emitter amplifier, the input AC signal to be amplified is applied across. In common emitter amplifier input is the emitter as well as base. These two are input terminals. Forward biased emitter base junction. So push yourself to be great, and we'll see in the next video with another subtopic. Bye.